Our next unit is inequalities, and essentially an inequality is anything that's not equal. So we can have greater than, less than, greater than or equal to, less than or equal to, or you can even just have the symbol not equal to. All of those would be types of inequalities. Our essential question is comparing inequalities to solving equations. They're very similar, although there is one big difference that we're going to investigate right now. So we're starting off with an inequality that we know is true. -2 is less than 4. What happens when we add 2 to both sides? Golden rule, whatever we do to one side, we do to the other. For an equation, it keeps it equal. For an inequality, in this case, adding 2 to both sides also keeps it equal. When you subtract +2, something very similar happens. It also keeps it equal. But let's see what happens when we add or subtract a negative value. Again, we will start with that same true inequality, and we will add -2 to both sides this time. -2 plus -2 gives us a -4, and 4 plus -2 gives us 2. We still have a true inequality, and something very similar happens when we subtract -2. The inequality will still be true. So our investigation shows that if we add or subtract any value to both sides of an inequality following that golden rule, we will still have a true inequality. So far, solving inequalities is the same as solving equations. Let's see what happens when we take that same true inequality and multiply or divide. I'm going to start by multiplying both sides by a +2. We get -4 is less than 8. Still a true inequality. Again, something similar happens when we divide by a positive, so we'll move on to investigating what happens when we multiply or divide by a negative. Golden rule, whatever I do to one side, I do to the other. -2 times -2 is 4. 4 times -2 is -8. Is 4 less than -8? Of course, the answer is no. This demonstrates the very big difference between solving equations and solving inequalities. If you multiply or divide both sides of an inequality by the same value, what you need to do is flip that inequality around in order for it to still be true. So now we have 4 is greater than -8, which is true. Let's take a look at what happens when we divide by a negative. Because something very similar happens. -2 divided by -2 is +1. 4 divided by -2 is -2. We have to flip that inequality around in order for it to still be true. Next, we're going to learn how to graph inequalities. So I'm starting off with an inequality, pretty basic. Y is less than 3. When I set up my number line, I usually mark 3 numbers on it. My solution goes in the center, and one value on either side to communicate how a number line is set up properly. If it's greater than or less than, we use an open circle. What that does is it expresses that that value is not actually a solution to the inequality. 3 is not less than 3, so it would not make the inequality true. However, of course, all of the values that are less than 3 would make the inequality true. So everything up to but not including 3 would make this inequality true. 3 values that would work, of course, we could have -1,628. We could have 0, or we could have 2.9968. The next inequality we're being asked to graph is very tricky because the variable is on the wrong side. Typically, we're used to reading left to right. This is -5 is less than or equal to x. And when you see that less than symbol, you think you should shade to the left. But if -5 is less than x, x is actually greater than or equal to -5. So if you flip the entire inequality around, it will be much easier to graph. The negatives also are a little bit trickier to graph because they work in backwards order. So -6 is less than -5. So the -6 needs to go to the left of -5 on your number line. With the or equal to, this time our circle is shaded in because -5 is greater than or equal to -5, so it does make that inequality true. Greater than shades to the right. All of the larger values are to the right of a number on a number line that's set up properly. 3 values that would make it true: -4.9999, -3, or 0. And finally, let's get into solving. The only thing we have to be careful of is when we multiply or divide by a negative, that inequality needs to flip. All of the other steps we learned to solve equations apply to solving inequalities. Starting off, I will subtract that 6 from both sides. So we have 10 is greater than -2r. Don't lose your negative sign. Dividing both sides by a negative value will cause my inequality symbol to flip. So I have -5 is less than r. Again, these are challenging to graph, so I recommend flipping the entire inequality, including that symbol, so that the variable is on the correct side, and you'll be able to set up your number line and shade in a little bit easier. R is greater than, so we have an open circle, and greater than shades to the right. Our final example, subtracting 3 from both sides. -37 minus 3 gives us a -40. Dividing both sides by 4. Notice the value we're dividing by is positive. Our answer is negative, but the value we divided by, 4, +4, does not flip that inequality. Again, we've got that variable on the right side, so we're going to flip the entire inequality to make our graphing easier. -10 goes in the center, -9 is larger than -10, and -11 is smaller than -10. We have or equal to, so we'll shade in our circle, and G is less than, so we shade to the left. Here are your 2 U-Try questions.